All right, welcome everyone to the Cluster Addons meeting. After some technical difficulties, we're in the race. On the agenda, we have review of action items from last time. Justin, you already said that you wanted to think about RBAC.
Yes. Yeah, so I have been thinking more about RBAC, trying to think about the idea of, I think this also comes up in Lee's doc, which we will talk about later on, I think. But the approaches that I've been grappling with so far are around having some external component, the same component which creates or installs the operators, maybe also create those RBAC roles, or maybe like bypassing RBAC entirely and then putting in some sort of alternate authorizer, like the node authorizer is an alternate authorizer for nodes, an add-on authorizer, but that feels like a very big hammer. So more thinking about the first one, but haven't really got much past the concept at this point.
Yeah, that brings up the question, how should we organize ourselves? Should we just file issues for this and then start adding documents to discuss it there, or what is the usual way of going about this?
I think issues and the design doc as Lee started are both great ways to do things. For this particular one, it might end up more as a doc, but we also don't have as far as I know, we don't have great ideas yet. So it's probably at the point where we can also make progress through discussion in these sort of forums if anyone has any ideas. And also by sort of talking about the issue repeatedly, maybe an idea will come to someone.
Okay.
Yeah, I look forward to fleshing that out a little bit more. I'm curious to hear what your ideas are in the node authorizer.
Yeah, I think that was all the actions up until now.
Also, I suppose Justin did mention this, but who is the contributor that's doing patch 44 on the kube builder repo, Justin?
It should be Jeff, if I'm guessing, I don't know the number. Jeff Johnson, who also works at Google, he is away at the moment, but I think he is, if 44 is the one I think it is, he is, yes, adding support for basically being able to specify patches in the sort of customize or kubectl patch or lots of other things sense, and specify those patches on the CRD instance itself. So for example, on your instance of core DNS, you could specify a patch and thereby change the behavior. You could change, for example, the resources that were required or that were specified by the core DNS deployment. It doesn't allow. The goal of this approach is to minimize the number of fields that you end up having to define, because you're not obligated as the author of an add-on operator to write a field for every value which a user out there might legitimately want to customize. You can pick the most common.
Node affinity, or
so like it gets into like a judgment call then at that point as to whether or not it's sufficiently popular. But you can also sort of say to people, well, look, like for now, just use a patch, and then if you see enough people that need to use it, you can smooth that process. So that's as you say, patch 44 in the kubebuilder declarative pattern repo, and I'll put a link to it in the notes in our. But Jeff is actually on holiday this week, I believe, or I think just today. But anyway, he's on holiday.
Okay. Cool. Yeah, I thought that was some really interesting work. All right, let's do a demo. So I need to grab screen sharing somehow. Let's try this.
If you don't have permissions, I will.
One share.
All right, you got it.
Are you guys seeing?
Yes.
This, my mouse moving? Yeah. And then I just need to move this Zoom thing somewhere non-annoying. All right. So the patch that I'm going to be demoing today is this core DNS operator using operator SDK. This is pull 8 on the add-ons operators repo. There's a lot of files. That's because I checked in the vendor directory from dep. This would, I think Justin's approach of using GoMod here is the way to go for sure. But this is how operator SDK generates your project, and I just went with it. That does simplify the checkout of the repository since the dependencies are pre-calculated for you when you clone in Git. So if I come here and I check out this patch, then we're on the branch, and there is a README. And here you can see that we've got like the classic makefile set up. And the first thing I'm going to do is, you can see that I'm not connected to Kubernetes right now. But if I do make kind cluster, what this is doing is using kind to set up a normal kubedm cluster, and then it's actually going to remove core DNS from the installation. So it's preparing an environment for me where core DNS is not installed. And that's obviously useful for developing this kind of problem. And if you look at the patch, I've tried to be pretty descriptive here in what's being accomplished and what's not. So we wanted to take operator SDK for a spin. And I found that it did things that I really liked. One of the major things that I found was useful as a dev that really turned me off from KubeBuilder was needing to modify my path during development using KubeBuilder. And I also got confused because KubeBuilder, it seems like it depends on specific versions of Kube API server. So that was a positive experience with Operator SDK, where you have a single binary that seems to encapsulate all of its dependencies for doing generation of APIs and things like that. It made it really easy to work with.
I recall having to actually install etcd when I tried to use KubeBuilder once, and then it expected a certain path.
Mm-hmm.
That was
let's talk about that. These are great pieces of feedback for that team, and I obviously have questions, but let's talk about those at the end. But yeah.
And then I did run into some issues, but here we have our kind cluster. There's no DNS service. I have to get my kubeconfig. So yeah, there's no DNS service in the kube system namespace. But then, if I make Docker build, and then I load the image into kind, and then I install the CRD and deploy it, it takes like, I think a little less than a minute or something like that. Obviously the image is cached since I've already pre-built this. And then it just loads it into the cluster and applies all of the manifests. I did have to do some nasty stuff in the makefile when applying the manifests to like template values for replacing namespaces and stuff like that. But it's all in there. And what that gets you is the operator installed in the cluster. So here's the deployment. And then here you can just see that we have the Kubernetes service and a pod. And so if I do get core DNS, there's nothing. But if I make install the custom resource, then now there's a core DNS in there. And if I get all, you can see that core DNS has been installed into my active namespace, and that the cluster IP was calculated properly. So that's the 10th address of the service subnet, which has been calculated using an improved version of Justin's function that's agnostic to IPv4 or IPv6. It's just a small change. And then What's kind of cool about this is, oh, well, I guess you should also see that there's the config map here. There's an operator lock here. That's just for leader election on the operator. And then here's the example core DNS config map, which what you'll notice is that if you actually look at the manifest that was applied to the cluster, it doesn't have a core file here. But if I describe the config map, you can see that there is a core file. So that's been placed there by the operator. If I edit the config map such that like I remove, say pods insecure, say I don't like that option, then now when I describe the config map, should converge. Oh, did it not take my edit? Yeah, sorry.
Does core DNS watch the file?
There we go. Yes, it does. So
the operator doesn't have to worry about that part.
Yeah, that's because the reload plugin right here is defined in the default config. If the user didn't want that, then you would have to orchestrate some rolling update. So that could be an option on the core DNS config map, or sorry, core DNS CRD.
Well, it sounds like it may be actually, I mean, I guess in this context, it would make sense to say that that option could be something that the operator must enforce, because otherwise config map is kind of useless, right? Otherwise
yeah, I mean, the config map is basically the only way to configure core DNS with like Kubernetes primitives, is using a core file mounted. But versioning the config map and hashing the contents and then naming it after the hash and then updating the deployment is something that the operator could do with, probably another 20 lines of code, I think. But yeah, if you edit the core DNS, oh, I was editing the config map, wasn't I? So yeah, I was editing the wrong thing. Here we go. So say I wanted to switch cluster DNS to false, because that's an option on the core DNS, and then I don't want the pods insecure option anymore. I can save that. Then when I describe the config map, you can see that it's removed the option from there. That should reload in the core DNS pod. And then similarly, if I describe or just get the services, then you can see that I no longer am the primary DNS server for the cluster. It's recreated the service. So that's the operator functioning for those two different use cases.
So yes, I was trying to this is very good, Lee. Thanks so much. I'm just sort of thinking out loud, really. It seems like most of the things that go into this core file are critical to the functionality of the operator and actual core DNS. Like, for example, the path to resolve conf and reload, as we just said, and port 53 at the very top. So those things, if you change those in any way, the whole thing would probably break.
Yes.
So it seems like maybe there's a certain set of things that have to be built into the operator, and then user adds extras on top of that, just as an idea, right?
Yeah, Justin's operator has a useful abstraction. I think that basically the core file has some special strings that the operator is capable of templating into it. It's a pretty common pattern from, like if you look at like the Puppet world and stuff like that, where there's, a standard templating behavior, and then the user can provide some configuration string for which operator abstractions or like some module abstraction, those values get interpolated.
Yeah, I mean, I'd say this is an important question we should definitely figure out. It's not necessarily like which technique to use. I think my implementation basically didn't allow any end user specification of the core file, whereas Lee's implementation does. And I think there are obvious shortcomings to both extremes, like a lack of customization and a lack of validation. And I don't know where we fall, but that's something we're gonna have to figure out. But it's
I mean, one thing that one potential way to think about that seems like we could consider having this base config that can be overridden somehow, but in order to override it, user has to do something that obviously looks like they are overriding some critical functionality, and they really have to know what they're doing, right?
Yes. Well, for one, just as a reminder, I did not specify a config. That was defaulted to by the operator automatically.
So yeah, maybe that field is like a core file override or whatever.
Yes, that is basically an override there. It gets set during runtime, similar to a cluster IP.
Interesting. Okay.
But if you provide it, the operator is not going to mess with your declarations. Which that kind of behavior is something that I think that's the minimum that you can do. I like the idea of providing flexible interfaces that maybe have a little bit of a better user experience, or maybe depending on the stability guarantees of the core file, like vendoring some libraries into the operator from core DNS in order to validate the config, and then post status messages onto the CRD or something. But I don't really know if that's very useful, because you can do like rolling updates and stuff in Kubernetes. Like we could remove the reload plugin and then use the deployments rolling update with multiple replicas or something.
But I actually think we should get the core file to use the Kubernetes API machinery, and then everything else becomes much easier. Exactly.
Yeah.
Like none of this legacy stuff.
Yeah, but then we could create some kind of temporary mapping layer where we show this being part of the Kubernetes object and getting rendered into the core file syntax.
Yeah, for me, it's just that like the mapping layer needs to be future complete, like because I've run into issues, say with using Prometheus operator, where they put flags to change TSDB settings, on Prometheus, and then Prometheus operator still months later from now, after I've reported the issue and found the bits of code to change and just not had the chance to update the CRD, right, and update the operator. So those things are still not usable. And it's because you have to change 3 layers of indirection, for that to bubble up, and the contributors from the other project don't know.
Yeah, but then maybe we could leave the room for somebody to provide a core file as a string as well, and have just thinking out loud, right? Have a subset of behavior exposed natively through some set of fields, and have a way to set a core file if one really must do so.
Similar to this, but then you just bolt on additional fields to change the generation function of the default. I like that.
And I think there are interesting high-level things in here, and it seems like there are interesting high-level use cases that we probably must explore at some point. I think I would say that it is the only thing actually I can think of is the like it'd be nice to be able to add extra Kubernetes blocks in there with other domains when you want to point the core DNS to additional clusters and do some sort of cross-cluster service discovery.
Yeah, that's exactly what I was thinking with this, because you can specify your own core file with multiple, like zone delegation or whatever, and then you can do cluster DNS true, and then you can have multiple core DNSs, scheduled however you like, with cluster DNS set to false.
Oh,
right, and then you can build a multi-instance topology using these resources. So.
Yeah, but I thought you could do it in one core DNS. You could just add where you have the Kubernetes cluster local blah blah thing. You could just add more of those things.
Oh, like just modifying this config.
Yeah, so you could have like you could have like a high level, just brainstorming to be honest, but a high level field where you say extra clusters or connect with clusters, and you specify addresses of API service that are external to this thing. Then
I'm sure somebody who's in
cluster
would be interested in that.
Just as an idea, right? But like aside from that, do we think there are any other use cases? I mean, caching parameters or anything like that that one might want to optimize, or
the one thing I kind of in hindsight, I wish I would have proxied the cluster IP field into the spec, because there's no way. So you can specify whether a cluster DNS is true or not, but you cannot control this value if it is false. So that's one thing that it's like as soon as you build these custom resources on top, right? Like it's a leaky abstraction. So not that this is mutable. So I don't know. And maybe arguably you should never care what this value is, but it makes it kind of difficult if you really want to like use the 11th address and the 12th address or something for reasons.
Yeah, this is I think one of those problems that as part of this group we should discuss more, because with DNS you have this issue where there's this thing that gets passed around as a kubelet flag, and it is also a field in a service, and those definitely link up, but there is no inherent linkage there. So I was wondering whether we should consider trying to solve some of those problems somehow specifically. So one other similar thing, which is rather very similar. So I mean, the two about DNS is that the domain name is something that is part of the DNS configuration, and it's also passed in as a kubelet flag. Okay, we have a default, which is something everybody agreed on. But like the IP address is a bit trickier, and the other very similar thing that I've encountered in EKS, or well, I guess more generally, it's a thing that can be observed in the AWS VPC CNI thing, the VPC network driver by AWS that uses elastic network interfaces and secondary APs on elastic network interfaces as pod APs. So that brings up a limitation to maximum number of pods one kubelet can run, which is based on the instance type. So essentially, if you're to use AWS CNI network driver, you need to set max pods in your kubelet config file or kubelet system as a flag. So
I'm not sure how it relates to core DNS, but if there's a
it is something that is the network piece is effectively an add-on, that imposes a kubelet flag. Similarly, DNS imposes cluster.local.
That's a component config thing.
Sort of, yeah. It's
let's chat about that in the component standard working group.
Well, I guess, but it's. I mean, in certain, I think it is an add-ons thing as well. I mean, because
I do agree. Yeah, that it's in the same space.
Yeah. So I'm not saying that it's something we should jump into addressing, but it seems like something that we should plausibly. It would be plausible to discuss a bit more far down the line, because it seems like there are certain add-ons that do have those kind of implications, and I wonder whether there is a way to address those, or if we are going to say that no, there is no way to address this. We're never ever going to address this, and anybody who has a special use case like that has to deal with that use case.
I think we should I think we should absolutely tackle those issues. But I think at the same time, that is common. We now have two approaches. We might be about to have three, but we have two approaches. And I think that those issues are common to both approaches, whereas I think we should look at the things that are different between the two approaches and try to understand the strengths and weaknesses of each, right? Like, so for example, the path thing felt like a difference. It feels fixable, but it feels like a difference. And I was actually like, thank you so much for doing this, Lee, because I thought the difference between the two approaches was actually at the end of the day very small, and actually boiled down primarily to whether in your code you built the objects, the Kubernetes objects in code, and in the I guess my code, but the other one, we built it by essentially loading a YAML file. And I guess my first question is like, do you know if Operator SDK mandates that, or?
Oh, definitely not. In fact, I started rendering the declarative pattern. The control loops that are generated are by Operator SDK and KubeBuilder are very similar, as well as the dependencies. Yes.
Yeah, I was like, if we put the pattern into Operator SDK, it felt like they would be
exactly like the same.
Yeah.
Yeah.
So I was like, that seems,
especially if you did the GoMod hacks that you did.
I feel like GoMod is either way, we should, like, one day we'll get there. But I'm sure I would have also had 9,000 files in my PR if I had not done it.
And then like the only thing to really consider is trying out the Operator SDK UX is obviously different. And then they have like an opinionated build with the Docker file, as well as you can use like Builda, I think. And then they have integration. So the one additional dependency that's not a Kubernetes dependency in the Go package is from CoreOS, and it's from Prometheus Operator for, I believe, Service Monitor. So I would be surprised if that was available in KubeBuilder, but basically that's instrumenting the operator.
Which feels, that feels pretty easy to add to either system, I guess. Yeah.
Yeah.
Either remove or add to the other or whatever.
Especially after chatting with Lucas, I'm not sure, how much Red Hat folks want to comment on upstreaming or like doing kind of something governance related with Operator SDK and like merging it into KubeBuilder. But obviously we have existing initiatives to, get all of the KCM loops to be KubeBuilder loops. And it makes sense, to have the community using unified tooling. Not that multiple ways can't exist, but for upstream components, it makes sense to use KubeBuilder, in my opinion. They're really similar.
I guess the question I would have then is, do you, Lee, and do we as a group prefer the declarative to approach where we essentially have a YAML file, or do we think we want to build them in code? And I have biases, and I can tell you, like, we can.
So I commented in my patch that like this was time consuming.
I didn't know whether you thought it was time consuming but worthwhile, or time consuming but not worthwhile.
Yeah, and I mean, I guess it's like you can. I don't even know which patch this was. Probably this one has like all of the constructors in it. Yeah, I mean, I don't know if this is really less frustrating than YAML. I think like really, if I reflect on authoring YAML, it's usually copying and pasting from other places and like making sure field names are correct, and then trying to apply them to the cluster and running into type errors. I don't know if like authoring. I just feel like authoring Kubernetes YAML, the tool chain is like not good. I certainly
agree we should validate.
Yeah. So I mean, as far as like knowing that this was correct, as soon as it was written, I didn't have any problems. So that's a thing. But
yeah, I'd say the two questions I want to ask are like, do we then have to? So I think the advantages are that a YAML file is more what our intended audience of like a core DNS developer will sort of expect. Like they've been writing a YAML file today. Now they can wrap it in an operator without too much work. And then I guess the question that I have is do we have a way to not have to build a new operator? So like if they release if core DNS releases 1.3.2, like it looks like, I think I saw 1.3.1, we have to build a new operator, right?
Yes. Yeah, you would have to build.
Yeah. Which is a little bit more.
I think there are quite a few trade-offs here. Definitely, I definitely appreciate some of the benefits that you get when you write out the Go structs, and you know, if you did that, your program compiles. You're pretty much well set. It's like if you check the YAML, you have to then use bin data or whatever to add that in, and then you have to test that and do all that stuff, right?
Well, we don't have to use bin data, but okay, yes, you just have to know the testing cases is harder, yes.
Yeah, you need to make sure those are in place. And one thing that I found is something that you may wish to address here or elsewhere. I mean, I'm hoping to start addressing that somehow. Is basically that if you have like a list defined in YAML, say, parse or you know, a multi-doc, parsing that and loading that in, and creating or updating objects based on that list is surprisingly much harder than I ever hoped.
Yeah. So I just want to move on. I'm not really.
I'm happy to talk about that later, but yeah.
In the document that I posted, I have a whole section on packaging, which I don't think that a Go file with a bunch of structs in it is acceptable packaging. So to your point, Justin, I would be very interested to have a more full understanding of KubeBuilder and the declarative pattern, but I excluded it because this was my first foray into operators.
Yeah, that's great. And I'm happy to give like a quick focus demonstration because, like, to Ilya's point, yes, it is more work than you would expect, and we've put that boilerplate into the declarative pattern along with like being able to load from like files or HTTPS or the bundles in the API server type thing. So
there's other fancy stuff in there that's like epic hard to do, like reconciliation of files, like when they're related things are different and stuff like that, which I have comments on in this patch. What I do want to highlight though is that if you look at this commit, this is a productive thing to look at, is the updating operator RBAC with granular permissions and comments. I think that something like this is going to be good practice for distribution of anything that requires privileged installation. So even if you're not using an operator, but you should have like some distribution of RBAC definitions that can be purposed for what you need in a specific namespace or set of namespaces. And you could maybe key that by like some namespace key that gets overridden by user options. And then also the cluster-wide things. And they're split up into separate rules. So if you don't know the RBAC API, like you can specify redundant rules that override each other, and they all eventually union together to be one effective thing. You can also bind multiple things from multiple levels to the same service account. So that's a thing. Like I'm using role bindings and cluster role bindings to get the proper mixture of permissions for a single service account across the cluster for certain things and in a namespace for certain things. There are other weird things in here that I expected Operator SDK to generate for me nicely that we should fix. And the same thing in KubeBuilder, which is that like leader election should have its own section so that that never gets conflated when the user is trying to mutate their own things. Really, I think it's an interesting thought experiment to explore how we could generate these rather complex definitions. But right now, the reality is that you need to know how to write these things, and you need to know what your operator is doing, and what verbs it needs, and what API groups and resources it's operating on. There's things that are not incredibly clear, like what the name of a CRD is, and how to reference it. But yeah, this ended up being more granular than what's on Justin's PR, and I think that's probably just a function of time and attention. So that's a learning thing there, but the comments are helpful.
Yeah, we should definitely make sure we have the comments. I love that. I'm conscious of time. Sorry.
Yes, let's move on. If again, all of this stuff is in the open. Yeah.
Real quick, I'm Joe from the Operator SDK team.
Mm-hmm.
So first, this looks great. Thanks for a lot of the feedback. The other thing I want to bring up, since you mentioned it, is that we've started to look at the possibility of how we might converge KubeBuilder and Operator SDK. So if you guys have thoughts on what you think would be good to pull into KubeBuilder from SDK or vice versa, definitely would be interested to continue that conversation. One point about the RBAC stuff that you were just talking about, so the Operator SDK has a Helm chart support, which actually will parse the Helm charts and generate all of this RBAC from the Helm chart. So that could be something interesting to look at in terms of inspiration for how to do this.
Mm-hmm.
Yeah, and KubeBuilder has the ability to look at your comments, but it doesn't do, your comments in your code, but it doesn't comment the output YAML. So I really we should get that more granular. But yeah, I don't know if Operator SDK has granular output.
Yeah, and outputting YAML from Go that has comments in it is kind of non-trivial. So anyway, thank you, Joe. That would be really good to make some progress there on factoring the projects together. So I want to definitely give Evan some time to talk about OLM, because I was really looking into it, and it looks like we might, in my opinion, there's nothing that's doing what OLM does. So I can give up sharing there. If anybody has any other comments, please post on the patch and go download it and run it and modify it.
Thanks a lot, Lee.
Yeah, thank you. I'm going to try and share my screen really quick. Is that good? And can everyone hear me?
Looks good.
Okay, so don't have a huge amount of time, so I think I'm probably just going to try and paint some broad strokes of what OLM is and attempts to do. But essentially, we are trying to think about Kubernetes applications and operators as extensions to the control plane via CRDs or API services. And so the question is, how do we open up the cluster for extension by developers and users? Apologize for the sirens. And so we try and think about what does it look like to have a set of extensions working together with dependencies, and how can we safely allow changes to those things over time? How do we deal with updates? And so the model that we have right now, the analogy that I like to use is very much for depackage and apt for RPM and Yum. So we actually have two separate pieces of software, the OLM operator and the catalog operator. And the OLM operator is sort of the analog to RPM or depackage. It manages just the individual packages themselves and the way we represent them. And very similar to those file specifications that you use for an operating system package, we collect up metadata about what an operator does and the way that it extends the cluster so that we can make decisions about what should or should not be allowed to happen. So we go to operating management really quick and just walk through some of this basic workflow that we have. So similar to how you might have in an operating system, we have a repository of operators for install. And let me find one. I've never installed Kong before, so I'm just going to see if this is even a good operator. So this is sort of the yum install equivalent, right? So I'm saying that I want, I want Kong to be installed and subscribe me to updates. So that's the main difference from like an OS package system, is that it's almost like mixing like an Omaha style update to operating system packages. So I'll install it here, and there is an intermediate step that I'm going to quickly gloss over, which is that we have install plans. So what happened is this generated an install plan, which tells me which packages are being managed by the cluster right now. And you can drill down into this and see what was installed and changed. So in this case, we created the CRD that I need. So this is an important part of OLN, is taking the ability to create CRDs away from end users and putting a layer of abstraction in between. So OLN creates a CRD for a user. And then it also created service accounts, cluster role binding that are required by the operator to run. And then CSV, the cluster service version, is the equivalent of our packaging format for an operator. And so we derive that all these things are needed from the definition of the CSV. So I'm going to go and look at this just as an example. So the main thing that we use when we're doing this is an operator describes which CRDs it requires to run. So in this case, this is the one that this operator is responsible for managing. So this indicates to us that in order to use a Kong object, you need to have this Kong operator installed and running. And the other thing we use this for is for saying things like, once I have this installed, I can't create another operator that also says it owns Kong, because they'll start fighting for control of the Kong CR. This doesn't have any dependencies, but there's also, you can write in requirements and you can depend on another operator. And then during that install step, we would go and find a provider of that API and install it for you. Much like custom resource definitions, we install API services if necessary. This is not an API service, so it's empty. But the syntax is much the same. We set up all the aggregation and API services for you and wire it through, so that if you want to write an operator as an API service instead of as a CRD-based operator, you can do that. Another thing that comes into play when we're dealing with extensions to the cluster is where operators are allowed to operate. And so this is, I think, sort of where the first bit of complexity comes in, because if you have, for example, an operator installed watching all namespaces and an operator installed watching a single namespace, but they attempt to use the same APIs, you have a problem. And so not all operators can be configured to watch all namespaces or one namespace or many. And so we ask packages to tell us which things they can do. And then via downward APIs, they can know the way in which they've been installed and configure themselves properly. So this is all sort of like the metadata around like what OLM needs to know to install and run a thing. We also have requirements for the operator itself. So in this case, this says that in order to install this operator, it needs to have these permissions. Cluster permissions indicate that it needs to know the cluster scope. So when I created that subscription and that install plan, the catalog operator, we call it, which is that yum equivalent, went and figured out all of the necessary RBAC from reading this description here. If you're not using the catalog operator and I create the CSV directly, it doesn't create it for you. It just whip blocks and says, I don't have permission to install it. Here's the permission I need. Please create something that has this permission. So when we're talking about the relevance to cluster add-ons, I'm not sure, like, there might be a stage at which we say we don't want automatic resolution of this type of thing. It needs to be bootstrapped in some way. Like, it's very much a two-stage process. And then if all of those things are met, then we have a definition of an operator purely as a set of deployments. And so again, this is where it gets its, the namespaces that it should be watching when it starts up. And then we have a bunch of status around what things are happening for this operator. So in theory, this should now be running successfully. succeeded. And then I should be able to create a Kong. I have no idea what this does because I've never used it before. Seems like it creates a bunch of ingress, which you would expect for Kong. Some of the stuff, so the reason I'm using the UI is because we also collect some information around what the CR is doing. And so I can associate the CR with things that have been created because of the CR in the UI. I'm just running a Minikube. This isn't OpenShift. I'm just running the.
Do you know if that's using owner references, Jeff? Like, is that just a controller on owner refs?
Yeah, this is using owner references, but it's we because there's not a way to query owner references directly. The packaging spec just says, tell me which types of resources to look for, and then we query for those and filter based on them.
So it's dynamically creating a controller to get that info.
Well, this is actually, this is all client side to determine this.
Okay, cool, thanks.
We could easily do it, we could do it server side and then add labels and use the labels to query client side instead or something like that. So one thing to show, I guess, might be if I go into service accounts and our role bindings, and if I delete this role binding, I should see my operator go unhealthy eventually.
A question: does it go unhealthy, or does it eventually reconcile it or fix it, as it were? Put it back.
That was the distinction I was going to make, was that it just goes unhealthy for now. The CSV just detects like whether it's in the correct state to install an update.
That makes sense, because if you wanted to revoke it, you wouldn't want to be fighting. There's probably more mature ways to do that kind of thing, but yeah, if a role binding disappears, there's probably a good reason. That's something I didn't talk about in my patch, but each core DNS gets its own sets of role bindings. Even the cluster ones are namespaced by name, so you can revoke individuals. But,
makes sense.
Yeah.
That's kind of, I think, as much time as I have to go into details right now. The only things I want to mention is that like the things that we're looking at for the near future and the reasons we want to be involved here is particularly around the packaging side. So right now it's a big YAML file that points to an image, and you'll have to have it via deployment and that kind of thing. And so some of the things that we're thinking about is like what's the best way to represent a set of resources that represents an operator as an object that you interact with in the cluster. And so we're thinking about analogs to like Helm has a OCI-based format, and ORAS has an OCI-based format for various sets of YAML manifests. It might make sense to use something similar for operators, or even use one of those existing formats if it makes sense to use. And so that kind of changes those APIs a lot, because there's less stuff directly in the YAML in the cluster that you see, and there's more stuff in image definition, similar to container images.
And that's the equivalent of the big YAML file you had showed at the start, with had the CRDs and then the deployments and the cluster roles.
Yeah, it would be very similar to that, just bundled up into one artifact that you can pass around.
Yeah, I was almost wondering why you had that, and why, how much of that can just be inferred from the YAML manifest that you're going to kubectl apply anyway.
Well, that's That is the artifact essentially. So the cluster service version is all those things combined so that you can atomically create and destroy them. But if you have some way to talk about a set of resources as a single entity, then you might not need a real YAML object in kube to do that. You might just reference one.
What was that second OCI format you talked about? There was the Helm 3 format, and then
It's called ORAS or ORAS. It's the one that I think it's a Microsoft thing. Something CNAB, setting the bell, the cluster data.
part of CNAB.
I think it's part of CNAB. I think it's the I might be mixing stuff up, but I'm pretty sure it's the registry side of CNAB.
Yeah, I think the packaging conversation is really important. It's as important as the security conversation. Like Daniel said, please go read the doc. We've started some enumeration of things to talk about there. I also like the idea of just a customized base in a Git repo referred to by HashiCorp's Git library as a package. I think that's a really solid idea from the customized project, because as an operator, as a human being working with Kubernetes clusters, like setting up Helm chart repositories and stuff like that is oftentimes unnecessary, especially when you're just trying to fork something or extend something in a really simple manner. Supporting a Git repo is a good move. But yeah, supporting that ORAS format from CNAB could be a really powerful community-sensitive move as well.
Yeah, we should try to stick with things that are part of Kubernetes, I think, and not things that are not part of Kubernetes. But we should try to figure out what that offers to us that we don't
CNI
get
is not part of Kubernetes.
Okay.
So, I mean, like having a packaging format that the community is already ratified makes sense.
I'm just saying, before we go outside the community, we should look at what we have in the community, I think.
Maybe just supporting the repo would be good then, because that's what customized does.
Yeah.
So customized as a Git-based packaging format for sets of YAMLs. Okay? Yeah, that might just be the thing to go with if that's already part of the kube world.
Yeah, it looks really useful. Thank you so much for the short demo.
Yeah, thank you. That was really great. It's great to see.
I can share. I have a whole big presentation if you want me to share it, so you can go read through more of the details.
Definitely put it if you want to put it in the agenda, that would be that wants to see. Because I'm sorry we cut short your time a little bit. If you're able to paste the link into the agenda, that'd be great.
Yeah, and any other resources as well if you want to link people to videos or blog posts. I linked to blog posts that a contributor talked about OLM in the chat. So
could also give you some time in the next meeting.
Absolutely.
So we can do
I really think that it's a powerful component. The dependency management bit is like very good. So because if you have stuff that depends on custom resources and the CRD is not installed, like cluster bootstrap doesn't even make any sense. You have to have some kind of ordered DAG. So
yeah, so there's one, we haven't done this yet, but one thing we wanted to try playing with was like, can we do something almost like BootKube, where we have just enough Kubernetes around to start up cluster components, but then package all those cluster components as OLM things. So essentially like BootKube plus stripped down OLM, just so that you can like package parts of Kubernetes as, again, things that describe the way they interact with each other, so you can make decisions about them.
Yeah, there's a section at the bottom of the doc about add-on management, which is exactly like in the space of OLM. So that doc that we have to postpone because of time. But there's a section at the bottom for like example proposals. If like you want to write some interesting ideas with regard to paring down components or just proposing outright using them.
Sure.
I already wrote an example for using OLM to manage operators or manage add-ons as operators. So
Cool. Yeah, I'll find that doc and see what's going on.
yeah. Cool.
Yeah, I think we're at time,
yeah,
right?
we're
So, like
over.
as you say, Daniel, then sorry, as you say, Lee, we probably should punt your thing to next time, if that's all right. But please, everyone that's here, have a look on in the agenda. There is a link to Lee's doc, which describes a lot of the problem space, where we can, I guess, have that discussion. And as Lee suggests, get that back into CAPS and update the original CAP and do all of those sorts of things. And I think, Lee, you and I should also figure out how we feel about the two add-on operator approaches, and anyone else wants to comment on them, please do so. It does seem like, I don't know, I felt like there was a movement towards going more declarative and looking at what that would look like, even with operator CK. And I think the nice thing is that then honestly, I don't see much difference. So if we want to use operator CK, that's great. But yeah, let's talk about that more next time, I guess.
Brilliant. All right. Thanks, everyone. And I guess we'll see each other in 2 weeks.
Or next week at KubeCon.
Oh, that's right.
Yeah.
All right. See you around.
Thanks. Bye.
Thank you, everyone.